So we are going to solve October-November 24, paper 4, variant 1, mechanics 1. It's a total 50 marks question and paper and 1 hour and 15 minutes time. Let's start with the question number 1, my dear students. Question says two particles of mass 1.8 and 1.2 kilogram are connected by a light inextensible string that pass over a fixed pulley. The particles hang vertically. The system is released from rest. So both are vertically. So you can make a pulley first like that. You can make the particles hanging one on each side. The first particle. Here is the second particle on the right side to the pulley, as you can see. Both are in vertical position. So label them. One of them is 1.8 kilograms. Other is 1.2 kilograms. Okay. Now, dear students, initially at rest, find the magnitude of acceleration and tension. It's a very easy question. So what you have to do with the black color, I'm telling you, this has downward force mg, which will be 1.8 times g. This has downward force mg, which will be 1.2 times g. Both of them have tension up towards the pulley. Now, first you decide the direction of motion. As you know that the 1.8 is heavy, so this motion is down and this motion is up. So what you have to do, you need to write two equations. Very easy question, my dear students. So one equation you will write for 1.8 kilograms. You write Newton's second law, the ma is equals to F net. So m is 1.8 af. So its forward force is the downward force, which is mg. So 1.8 into g, which is 10, minus the upward is tension. So 1.8a is 18 minus t. You got one equation. The same way you are going to get the other equation for 1.2 kilograms. This is how you have to present in the exam. So you again say Newton's second law, F net is equals to ma. This time force is mass is 1.2. A you want F net. No, it's forward force for 1.2 is the tension minus the weight. Weight is 1.2 times 10. So dear students, this is 1.2 A is equals to T minus 12. You got these two equations simultaneous. So you will add these two equations. Let's check how much is that. So it's going to be, add them. So it is 3a, tension will be simplified, is equals to 6. Acceleration is 2 meters per second square. My dear students, once you found the acceleration, you can substitute acceleration in any of the two equations. So I'm substituting in this one. It is going to be 1.2 into 2 and then plus 12 is equals to tension. So it is 2.4 plus 12 is the tension. The tension will be 14.4 newtons. It's an easy question. So what you have to do, you need to write two equations for each particle. ma is equals to F net. You solve them simultaneously. You get the tension, you get the acceleration. It's an easy level of question. Proceed to question number 2. A particle of mass 7.5 kilogram starting from rest at A slides down inclined plane AB. The point B is 12.5 meters vertically below A as shown in the diagram. Given that the plane is smooth, smooth means no friction, use energy method. Principle of conservation of energy says the loss in GPE is equals to gain in kinetic energy. Since it was already at a certain height, so it had GPE here. When it came down, it has lost GPE and it gained this velocity, so it has kinetic energy. So what do you say? You say loss in GPE is equals to gain in kinetic energy. Loss in GPE is mgh. Gain in kinetic energy is half mv square. M could be simplified. So G, which you take 10, 12.5 half v square. 125 divided by 0.5 v square, you take square root, v will be 15.8 meters per second. Next, it is given that instead the plane is rough and the particle reaches B with this speed. Plane is 25-meter long and constant friction force is F. Find F. Okay, so what will we do? We'll draw this diagram again as it was given so that you can understand. Now initial height is still same, which is 12.5 meters. They say the length of the plane is 25 meters this way. All right, and the friction which is opposing is F, and you reach with the speed 8. Now principle of conservation of energy says, as you said before, now you will say loss in gravitational potential energy is gain in kinetic energy plus the work done against friction. Let's use energy method over here. So loss in GPE, we substitute the values. M, the mass we already know, which is 7.5. G, H is 12.5. Gain in kinetic energy, half, 7.5. Speed, they told you it gained 8 meters per second. Work done against friction is frictional force times 25. You rearrange this equation. So let's solve. All right. Now I will solve for you using forces method, right? Harder. So let me try the same question for you using forces method. Whenever you need forces method, first of all, you need to know what is the acceleration. So first of all, let's find acceleration. I'm going to solve this question using forces, my dear. Just stay with me and listen what I'm going to do. So you already know the initial speed is 0. Final speed, they gave you how much? 8. Acceleration I want. Distance traveled was 25. So v square is equals to u square plus 2as. 8 square is equals to 0 square plus 2 into a into 25. When you rearrange, your acceleration is going to be 1.28 meters per second square. Now apply Newton's second law of motion, which says ma is equals to F net. So my dear, m mass is 7.5, a is 1.28, forward force is the weight component. Weight component is mg sine. Now in that case, my dear, you need to know the sine. So I will go here. The sine is very easy to find. If this is theta, so sine theta will be opposite, which is 12.5 over hypotenuse is 25, which is sine theta is 0.5. Okay, so you will do forward is mg sine theta. So mg sine theta is 0.5 minus backward is friction. It should be exactly the same answer, 27.9 Newton. Clear? So I did this question two ways. Certainly energy method is easy. And how my approach goes for energy method first, because first question itself is energy and Newton's law of motion we already applied to the first question. We proceed to that question number 3, my dear students. Question 3 is one of the easiest question. You all should consider this question like to-do list, like it's easy. You have to get full marks in this. Coplanar forces of 52, 39 and p Newton act, showing in the diagram it is equilibrium. So equilibrium means resultant force is 0 and all the components in opposite direction, they balance each other. So since the components have to balance each other, so you resolute on both axes, the vertical axis and horizontal axis. So dear students, the 39, no need to resolute, already on x-axis. 59, 52, no need to resolute, it is already on y-axis. So this will be p cosine theta to the left side. This will be p sine theta to the right side. So when you equate them, my dear, the left is equal to right. P cosine theta is 39 and p sine theta down is equal to up, which is 52. Whenever you have sine and cosine, you need to divide them to get 10. So p sine theta divided by p cosine theta, it is 52 over 39. Dear students, p cancel with p. Sine over cosine is tan theta is 52 over 39. So theta will be tan inverse 52 over 39. So dear students, theta comes to be 53.1 degrees. Yes? All right. Now, since you know the theta, you can either apply Pythagoras theorem or you can directly put this theta in any of those given equations. So P will be using that equation 52 over sine theta. You calculate the P, which gives you 65 newtons. So that question is very easy. What you have to do, you have to resolute the forces. Equilibrium means you just equate the opposite components have to be equal. That's it. We proceed to the next question, which is question number 4. A bus travels between two stops A and B. The bus starts from rest at A and accelerates at constant rate. So constant acceleration means straight line graph until reaches the speed 16. So straight line graph until 16. It then travels at constant speed before decelerating at a constant rate coming to rest. It's a 100% trapezium graph, my dear students. Constant acceleration, constant speed, and then what? Constant deceleration. It doesn't matter how it looks like, but you need to make a trapezium because it is a sketch. Now what you need to do, you need to label the maximum velocity, which they gave you 16 meters per second, and nothing else is given. Yeah, total time is given, which is 240 seconds. Apart from that, nothing is required to be labeled, my dear students. Now if you move to the next part, find an expression in terms of A for the length of the time that the bus is traveling with the constant speed. So you need to find that this time, like from here till here, you can say from T1 till T2, but in terms of A, my dear students. So what can we do? We will make sections. Stage 1. Yeah, stage 1, my dear, it is the acceleration stage. So during the acceleration, we can find this time. So we can easily find the time because they told you initially you are reaching 16 meters per second and acceleration is A. So this time I will say T1. So you know that the acceleration is a change in velocity, which is 16 minus 0 over time T1. So it gives you T1 as 16 over A. Okay, now we go for stage 3. Stage 3. Stage 3 also, if I use the gradient method, so now acceleration in this time is 0.75 A, the gradient. 0.75 A is the gradient, and rise is 16, run is T3. So T3, my dear students, stage 3 will be 16 over 0.75, but A is in the denominator, my dear students. Yes? Okay, can you just calculate just 16 over 0.75, 64 over 3A. Okay, so the stage 2, which they want constant speed, so your time taken will be, total time is 240 minus 16 over A plus 64 over 3A. If you don't want to simplify, you can leave it. It is the expression, my dear. It's the right answer. If you want to simplify, just take 1 over A common, then it will be 16 plus 64 over 3. You can get it. Anyhow, this is how we do the first part. Now they want to move, given that the distance travel from A to B is 3000. Distance travel mean it is the total distance, mean it is total area under the graph total area under the graph is 3000 meters, which is trapezium. Trapezium area, my dear students, you all know it is the shorter base, the longer base over 2 times height of trapezium 3000. So area of the trapezium, as you can see, half you wrote. So A is 240, B is the shorter side, which you just calculate up, 240 minus 16 over A plus 64 over 3A. Okay, into, we were supposed to do the height, which is 16, the height of the trapezium, then equals to 3000. Now you will solve that. Half, yeah, 112 over 3A. A is denominator, my dear, into 16 is 3000. You can do shift solve. Answer is 16 over 45. In decimals, how much it comes, you can write that as well. Okay, my dear students? So this is how you have to do it. So area of the trapezium is the total distance traveled. You equate the area equals to 3000 and you solve it. The answer is 16 over 45. We proceed to question number 5, my dear students. This is a two-particle motion. It's a tricky question. Stay with me, my dear. A particle A is projected vertically upwards from the point O with a speed 80. Okay, so make a ground. Okay, project the particle A vertically upwards like that with initial speed 80 meters per second. All right. 1 second later, the particle B is a time gap question. So it means if B is late, so earlier is in a longer time of motion, my dear. So earlier particle, longer time of motion. Now they say 1 second later, my dear students. So here there is a trick which you need to take care of that. Dear students, 1 second later, a particle B with the same mass as A is projected vertically up from O with the speed 100 meters per second at t seconds after the first particle. So if for A the time is t, so for B the time is t minus 1. Earlier the particle, more the motion. So it has to be t minus 1, not t plus 1. Okay, so A, you know, initial speed is 80, acceleration is minus 10. B, initial speed is 100, and time is, the acceleration is also negative 10, my dear. Okay, now the question says they collide, one thing, and then they say they coalesce. Coalesce means they join together. Coalesce means they join together to form particle C. So first of all, show that the time is 3.5. So when they collide, it means they are at same height. So first of all, at collision, it means the distance traveled by A is same as displacement traveled by B. Both are in motion. You will use for both of them ut plus half at square, ut plus half at square. A, I'm using the left side, which is 80 t plus half a, the negative 10 t square. Right side, I'm using B, 100 t minus 1 plus half of negative 10 t minus 1 whole square. This will help us, my dear. So 80 t minus 5t square, 100 t minus 100 minus 5 t square minus 2t plus 1. Okay, we can simplify further. 80t minus 5t square, 100t minus 100 minus 5t square plus 10t minus 5. 5t square from both sides simplified. So I will simplify the right side first. 80t, 100t plus 10, 110t minus 105. We will solve this equation further. 105 will be 110t minus 80t. So 105 is equals to 30t. 105 divided by 30, 3.5. 3.5 seconds. Now 3.5 seconds is the time taken after the projection of A until they both collide. Now they say they coalesce. The coalesce mean they join together. Coalesce mean they both join together. So find the height above which they coalesce. Easy. It's very easy. Height, actually, you can use A, you can use B. So I'm using the first one. So height actually means what is S? I'm using SA is UT plus half AT square. So U was 100, right? Sorry, U was 80, 3.5 plus half negative 10, 3.5 square. It's just one mark, simple. You can calculate. Since it's exact answer, you don't have to round. If you round, you will lose the mark. We proceed to the next question. It's the same question, part C, my dear students. So we know at what height they coalesce, and we know what time did they take to reach there. Find the time from A being projected until C. C is actually A plus B, the connected particle. We cannot find until we know their collision speeds. So first of all, we need to find their velocities at collision, means velocities at time is equals to 3.5 seconds. So we will find for both of them v for A and we will find v for B first. They will be initial speeds of collisions. V is equals to u plus at. So for A, u was 80 plus negative 10 into 3.5. You calculate this, which is 45 meters per second. B is also ut, u plus 80. This was 100 plus negative 10, but the time is 3.5 minus 1, which is 100 minus 10 into 2.5. 100 minus 25, which is 75 meters per second. So they are colliding with these speeds. Now these are their speeds before collision. You apply the principle of conservation of momentum. It says m1 u1 m2 u2 is m1 plus m2 into new speed. Now we will find at what velocity they start to move. Let's see. So m1, their masses they gave us in the question, they are saying same masses. So we will just say m 45, m 75, 2m v. 45 plus 75, 120m is 2m v. 120m divided by 2m is v. M simplified, v is 60 meters per second. So it means this is the initial speed of C right after collision. Since we took the positive velocities up, for both of them, we took positive velocities for up. So now I will go for C. The initial speed is 60. Acceleration is negative 10. The height we found 218.75. And we need to find the time taken. So first of all, we will choose the equation which has these letters. S is equals to ut plus half at squared. This time we are going to find once it starts to move. So 218, but 218 now it's very important, we will use negative. Why? Because this motion is up, but the displacement final is down. Since its motion is up, but this displacement is down, so since displacement is opposite to the initial motion, you have to use negative sign. 218.75, you can write here the displacement is negative, my dear. So ut, which is 60, t we want, plus half negative 10 into t squared. It's a quadratic equation, my dear students. 218.75 60t minus 5t squared. So it is 5t squared minus 60t minus 218.75. You can use the mode 53 from the calculator to get the time. So time comes certainly the first time, the smaller time if they are positive, and if negative, you will ignore it. So 14.9 seconds. So this connected particle reaches the ground after 14.9. So you need from start. So from start, before that, the A was in motion for 3.5. So 14.9 plus 3.5, can you add them? 18.4 seconds. So it's a good question of momentum. This question is not as hard as the variant 2 and variant 3, but still you need to be very cautious when you are applying. Like when the call is, you need to know the speed before collision, then apply principle of conservation of momentum, and then find the new velocity. Velocity is up, but displacement is down. We use negative velocity. We proceed to question number 6, my dear students. Inclined plane. A particle of mass 1.2 kilogram is placed on a rough plane which is inclined at an angle theta to the horizontal. Sine theta is equals to 7/25. If you want to calculate theta, fine. If you just want what is cosine theta, you will do cosine of sine inverse of 7/25. It gives you what will be cosine theta. Or you can first find the just sign. This will give you exact fraction. Exact fraction. So cosine theta, my dear students, 24/25. Okay. Now we have sine theta, we have cosine theta. Question is, it is in the equilibrium, my dear students. So equilibrium, as you studied before, question 1 was also equilibrium or 2. So they say in this question, the held by equilibrium on the line, and the coefficient of friction is mu is 0.15. So it is held by that, the least possible value of P. Least value of P mean, so if it is least mean it is just about to fall down. So if least, the friction is opposite direction. If it is largest, opposite to the P. And if it is largest, friction is in the same direction. Yeah. So largest, no, it is same direction. So if it is least, so it means it is about to slide down, about to slide. Least value of a force which is holding, it means the body is about to move in this direction. Okay, like where it is stopping it. Yani you are not strong enough. If maximum value, you are very strong. Yes or no? Yeah. Let's start resoluting this, my dear students. So first of all, you find the cosine theta, and then they told you the mu is, as you can see, 0.15. Okay, so let's place the forces. This force, if you want to assume, you can assume this way, just to help you where the resoluted components will be. Now I'm going to use resolution perpendicular and parallel to the plane. So first of all, you know here it is going to be mg sine theta. Here you are going to have mg cosine theta. Here you are going to have r. Now since I push this force this way, so it means its angle using the geometrical property, this is also theta. So this will be the adjacent component, p cosine theta, and the down will be p sine theta. Now before we go for friction direction or path, can we just first relate the equation for r? Equation for r, my dear students. So r is going to be p sine theta. We are going to do r is equals to this one. So r is p sine theta plus mg cosine theta. Okay, so m is 1.2. Sine theta is 7/25. 1.2 times 10 times 24/25. So r is equals to, you can give me decimal value of 7/25, 0.2528, 0.28p, and 12 times 24/25, 11.52. Okay, now we will go for friction part, my dear students. So as I told you, least force means it is the weakest force. It is the weakest. So about to slide down, I told you already. So if it is about to slide down, so the frictional component Fc is up. Least force means weakest force. Maximum force means strongest force. If it is a weakest force, so about to slide down, so down is equal to up. We are going to equate these two components now. So mg sine theta is equal to Fc plus p cosine theta. Let's put, my dear students, mg 1.2 times 10 times sine theta is 7/25. Fc is mu r. Fc is what? Mu into r. Mu they gave us 0.15. R I will take from the upper part. This one I will substitute here, and 0.28p plus 11.52. Do shift solve, my dear. Plus p cosine theta is 24/25, my dear students. So you solve this equation. Can you give me the left hand side, Akram? 120 as 12 times 7/25, 3.36. Okay, 0.15 times this, p, 0.15 times 11.52, 1.728, 14/25, 0.28. 96 P. You can rearrange, solve the equation. It will lead you to get P 1.63 newtons. An easy question. This paper overall, I feel like it is easy paper. Certainly, it will have a very high threshold. Okay, we proceed to the next question. Question number 7. A car of mass 1,200 kilogram. When the car is traveling at a speed v, there is a resistive force kV. And the maximum power is this. You can write the data, my dear. You have power and you have mass and resistive force is Fr. You can say the car travels along the straight level road. Level road means horizontal road, my dear, has the greatest possible constant speed. Dear students, the constant speed mean acceleration is 0. Acceleration 0 mean F net is 0. F net 0 mean the forward force is balanced by the backward, which is resistive force. Forward force is the driving force of the car. Backward is the resistive force. If you know the power definition equation, we know the power is driving force multiplied by velocity. So the driving force is power over velocity and resistive force is kV. Substitute the value, my dear. Both the power is 92.16 kilo mean times 1000 over velocity they gave you. It is 48. K we don't know. Into velocity is 48. You rearrange, you solve. The K will be same what they ask you. 40, my dear students. Now we know the K is 40. It's just 1 mark question. We need to use this for the next section. At an instant, when the speed is this, now the speed is 45 and the greatest possible acceleration. We already know the power is 92.16 kilo, which is 92160 watt. We already know the mass is 1,200 kilograms. Newton's second law of motion says ma is equals to the driving force minus resistive force. M is 1,200. Acceleration we don't know. Driving force is power divided by speed, which you want to, which you have 45. Resistive force is kV. K we found, which is 40. V is 45. You can just rearrange the equation and get the acceleration. 31 over 150. Now you can give me 3 significant figures. 206, so 7 meters per second square. Okay, with this the part 2 is finished. We proceed to part B of question 7. Part B says the car now travels at a constant speed but uphill. Inclined plane, sine inverse is this. So theta is equals to sine inverse of 0.15. So sine theta is 0.15. You can make an inclined plane, my dear students, with the theta over here. The car is moving like this now. When car moves this way, you know there is a backward new force. Apart from the resistive force, there is mg sine theta, my dear students. Driving force is Fd. Again, constant speed you need to find. So again, use the same equation. Since acceleration is 0 for constant speed, so the driving force has to be equals to total resistive force. Driving force is P over V. Two resistive forces, one is kV, other is mg sine theta. Now power is the same power, my dear students, which is constant throughout 92,160 over the speed we want to find. I think it will form a quadratic equation this time. K was 40V, mg 1,200 times 10, sine theta is 0.15. Let's do simplification in one step. 92,160 over V is 40V plus 1,800. Okay, cross multiply by V to both of them. 92160, 40V square plus 1,800 V. Now, my dear students, 40V square plus 1,800 V plus minus 92160, 30.5 meters per second, minus me returning back, you will reject it, 75.5. So the maximum possible speed is while moving up is 30.5 meters per second. That was a good question. Now, I think there should be still another question with variable acceleration in which we need to do integration and differentiation to relate the acceleration, velocity, and displacement. Proceed to question number 8. A particle P moves in a straight line from through a point O with a velocity this. Okay. After time t, P passes O, the acceleration A is given by this. So A is equals to 0.6t minus 2.7. Find the distance P travels between the times of instantaneous rest. So this is your first task. Instantaneous rest mean you need to find velocity and put equals to 0. You know SVA. Okay, so if you want to go down to up, you integrate. So from velocity, acceleration to velocity, you have to first integrate the acceleration to get the velocity expression. So integrate 0.6t minus 2.7 with respect to t. Velocity is 0.6t squared over 2 minus 2.7t plus c, my dear students. So we need to make sure what is c. We will find c. It's not always 0. So this is 0.3t squared minus 2.7t plus c. Now let's find c. When time was 0, it started to move. Look here, my dear students. When time was 0, it started to move at speed 4.2. So substitute t is equals to 0 and v is equals to 4.2. If you substitute, so 4.2, 0 minus 0 plus c is equals to 4.2. Dear students, the velocity expression comes 0.3t squared minus 2.7t plus 4.2. Okay, now they mentioned find the distance until it was instantaneous rest. So rest mean we need to find those two times. So rest mean put velocity equals to 0. 0.3t squared minus 2.7t plus 4.2 is equals to 0. My dear students, if factors are possible, let's show. Can we all divide this all by 0.3? In that case, factors were not possible. Here factors are possible. T square minus 9t plus 14 is equals to 0. Now you can do the factorization. T is 2 and 7. So it means one factor is t minus 2, other factor is t minus 7 is equals to 0. So dear students, clearly write your first time is 2 seconds, your second time is 7 seconds. Now the question becomes very easy. 0 to, no, we only need between these two times. You need to distance travel between these times. So integrate is a definite integral, my dear students. Yeah, SVA, velocity to displacement. What you have to do, you integrate from 2 to 7, the velocity. Velocity was 0.3t squared minus 2.7t plus 4.2 dt. Dear students, I'm using the next page, which is the blank with me. So S is equals to, I'm integrating 0.3t 3 over 3 minus 2.7t 2 over 2 plus 4.2t. It's a definite integral. Just put 2 to 7. First simplify, my dear. 0.1 t cube minus 1.35 t squared plus 4.2t. I did not put c because it's a definite integral. What you have to do, you must show the substitutions of the values. So substitution you will do all with 7 minus then all with 2. This with 7, this with 2. In the end, you will subtract them. You can check your answer by using the calculator's integration sign by putting the actual equation, okay? But this must be shown, I'm telling you. If you don't show, you will lose a point. 6.25 meters. So my dear students, what you have to do, once you integrate, eventually, after integrating, your final answer comes 6.25 meters.